So, welcome back, one and all. Today, we can talk about a whole new subset, network analysis. So, this is basically the basics and fundamentals of the subject. And today, we're going to talk about the topic superposition theorem. So, instead of going through these points, if you want to read through them, you can pause and read the video, read the points. So, superposition theorem is basically a theorem when we use to find the current flowing through an element or the voltage flowing through an element when there are more than one or two sources. So if there is one voltage source and one current source, and due to this when due to these two source supplies, was the amount of current or voltage flowing through an element. So that's why we use superposition theorem. And superposition theorem is basically it is based on KCL or KVL. You can use any medium to you find the current or voltage flowing through it. So again, the superposition theorem is a circuit analysis theorem used to solve the network when there are two or more sources are present and are connected. So it's basically the same what I said. If you want to read this, you can pause. How to apply superposition theorem. So the first step is to select one among the multiple sources present in the bilateral network among the various sources in the circuit. Any one of the sources can be considered as first. Um, I would suggest I wouldn't explain using these points, but if you want to read this again, pause it and you can read the point. So superposition theorem, let's say there are three sources acting in the network, and you need to find the voltage or current flowing through one of the element. We take each supply source individually, and then we find the current or voltage flowing through the element. Let's say there are two voltage sources and one current source. When we consider one current source, we consider only the current flowing through the, let's say 20. Okay. Instead of saying, we'll take an example and try to understand. So let's say find the current flowing through 20 ohm using superposition theorem. So you can see that we have two sources, which is a 20 volt source and a 4 ampere source. And we need to find the current flowing through the 20 ohm resistor. So the first step is, no, the first understanding you need to do is we have two sources and we need to consider each source individually, and we need to find out the current flowing through the 20 ohm resistor. Let's say we consider the 20 volt source first, then we need to open circuit this. For current sources, when you're for the alternating, or when you consider the other sources, and you need other individually, and we need to short circuit current supplies, and we need to sorry we need to open circuit current supplies, and we need to short circuit the voltage supplies. So let's say we consider the 20 volt supply source first. Then you can see, yeah, so you can see that we don't have this branch which was there, the branch which contained the 4 ampere current source. Since we are considering 20 volt source individually, we need to short or open circuit the other branches. Since the other supply source was a current source, we had to open circuit this. Now you can use any medium. As I said, you can use KCL or KVL to find out the current flowing through the 20 volt resistor. If you use KCL, as you can see, you have here one node, and you can use this as the reference node. And using this, you can find the current flowing through the 20 volt resistor. If you use KVL, this is a loop one, and this is the other loop. And let's say loop one has a current I1 and loop two has current I2. Then the current flowing through the 20 ohm resistor is I2. So after calculating, you can see the steps over here. So we have used the nodal equation, which is the KCL, Kirchhoff's current law. So using this, we got I1 as 0.4 ampere. Now, when we say I1 here, we refer that the current flowing through the 20 ohm resistor, considering the 20 volt voltage source. So we have considered first source individually, and the current flowing through the 20 volt 20 ohm resistor due to the first source is 0.4 ampere. Now again, keep this aside. Now we have short circuited the 20-volt resistor. This is the step 2. Now we need to consider the 4 ampere source. Now we need to find out the current flowing through the 20 ohm resistor due to the 4 ampere current source. So you can see there are 3 loops, there are 2 nodes. You can take this as the reference node. Again, the same step, you need to find out the current flowing through the 20 ohm resistor. Loop 1, loop 2, loop 3, I1, I2, I3. Now over here, if you use KVL, you can see that the current flowing through the 20 ohm resistor is I1 minus I2 or I2 minus I1. You can take either one. You'll get the magnitude is same and magnitude of the current. If you use KCL, you have this node 1, node 2, and you can use the reference node. So you can see to simplify the circuit, you can see that 5 ohm and 10 ohm are in series in parallel with each other, and this when you take this equivalent circuit, this and this, they are in series with each other. Now you can see 40 by 3, that's the total resistance of the 5 and 10, the other 10 over there. Now you can see this and this, they both are parallel to each other. So of course, you can, if the circuit is so simple as in this network, you can use simple ways to calculate the current or voltage through a particular element. But when it comes to complicated elements where you have multiple sources and multiple elements, things might not be simple, and KVL and KCL might be the only way to solve the problems. So we get I2 after calculating. See, we get the total resistance over here as 40 by 3 into 20 by 40 by 3 plus 20, which is the total resistance for parallel resistors. So we have the current, we have the resistance. So we can find out the voltage. So V is equal to IR. Using Ohm's law, we get the voltage. And using that, we can find the current flowing through the 20 ohm resistors. Oh, sorry. We have used the current division law over here. So current division law, you can see this is the formula of current division law. IS is equal to R1 by R1 plus R2. So we get I2 as I1.6. So using the first voltage source individually, we got I1 as 0.4 ampere. And using the second source, which is the 4 ampere, we got the current flowing through the 20 ohm as 1.6 ampere. So after considering each individual source, we get I1, I2. So the total sum of all these currents is the total current flowing through the 20 ohm resistor, which is I is equal to I1 plus I2. I1 is equal to 0.4 and I2 is equal to 1.6. And as you can see, so the total current, which was in the first, this thing, the 20 ohm 20 ohm resistor, the total current flowing through the 20 ohm resistor due to the 20 volt source and the 4 ampere source is 0.4 plus 1.6, which is, you can see, 2 ampere. So this is the most basic question for or the basic example for superposition theorem. We'll see you in the further videos. Thank you.